So our next speaker, before the break, we're going to hear from Richard again, and he's going to give us a report of what we learned or found out we didn't know.
Okay, so this is dedicated to everybody who participated, and I just summarized it. So if whatever is wrong in this, it's my fault, but lots of people helped in coming up with ideas. Okay, can you move the thing forward? Okay, systematics. So we had 5 sessions. We talked first about the systematics. So what is the relationship of this beetle to other beetles known? What is the relationship of the fungus to other fungi known? What do we know about the biology of the beetles? What do we know about the biology of the fungal symbiont? What can we do to monitor this, and what kind of control strategies can we come up with? And finally, how does this thing spread through the environment? Oops, forward. Okay, so as we already touched upon a little bit, the identification of the ambrosia beetle in this case is a bit of a problem, since we think that we're dealing with a new species, and in order to get a name for a new species, you need some morphological difference. And we think that we deal with a new species because it's so different in its DNA sequences. And why would this be a problem, you say? Okay, we know this is not a species. Well, in order to find a name, you need to have an official description, and therefore you need a morphology. And so for all sort of regulatory activities and other things, having a name, a new name for this thing, is important. So for the time being, we just keep calling it Eualacia fornicatus as a scientific name, but for the common name, we've proposed to call it Polyphagus shothole borer. Polyphagus because it attacks so many different trees. So we talked about that for quite a bit. So this thing was originally described in 1868, and like I said, the beetles we find here in California and the ones we find in Israel are identical. And they differ from morphologically identical beetles that we find in Florida, Thailand, Sri Lanka, Australia, and Papua New Guinea. And these things are so different that our beetles are a different species from the ones in these other places. Okay, so we concluded as one of the things that needs to be done for this beetle is that some morphological specialist is going to stare really carefully at this thing and see if he can find some sort of a morphological feature that differs between the two. So then happily we can give it a new name and everybody is happy. So let's see. So we've worked around this thing by giving this thing, this beetle, a different common name, which is maybe also not quite legal in the whole naming world. But anyway, that's what we call it, Polyphagus shothole borer. Where does the thing come from? Well, we don't have the slightest idea. We know we find it in Israel. And there it's an invasive species. We find it here, it's an invasive species. Where in the world it originates, we don't know yet. We're trying to get beetle material from many different places. So I've also been using some slides of various of the speakers, and this indicates how many of these beetle species come in. And so these are just the interceptions of where the USDA or the USDA has intercepted different beetle species. And these are the numbers of, let's see, scolided interceptions. So I'm not quite sure if this is the number of interceptions. So when they find a beetle, so twice they found a beetle there. And you can see that the numbers that are intercepted are really high, like in Texas, 1,203, Florida, 1,100. We've had 240. And some of these ambrosia beetles, because of their way in which they mate within the gallery, so the only thing you need is one infected female, and she can start a whole new population, because she has mated she'll produce offspring, both sons and daughters, and the sons and daughters will happily mate inside the tree and start a new infestation. Okay, so these are the ones that are established in the US and Canada. So these are the number of species. Number of species on this axis, these are the decades, and you can see, let's say, in the decade of the 2000s, we got 11 new species established. So these things are coming in at a good clip. Okay, now, why are these identifications so difficult? Well, I'm not a systematist, but people that study the morphology of these things can tell the difference between these species, because there's a particular morphological shape that tells them it belongs to species A or B. So here you got R, Uwelacia fornicatus. This thing is called Adamadensis, Xanthopus, and Valledus. And you see they all, to the untrained eye, like mine, they all look very similar. Now, they are different species, and there are ways of telling them apart. Okay, so this is our species here. So this Israel and California, these two, and this is the part of the beetle that you use in order to identify them. And this is the one in Florida. DNA-wise, these things differ quite a bit. Morphology-wise, I don't know. I don't think so. They look very similar, yet they are different species. So then we talked about the fungal systematics. So the beetle and the fungus, they always come together. The fungal symbiont was also new to science. It belongs to Fusarium. This group has both virulent fungi and Ambrosia beetle symbionts. So symbionts that just, the only thing they do is generally infest the tree a little bit, the beetle feeds on it, and it doesn't have any other consequences for the tree. There is an excellent fungal characterization system based on a whole bunch of DNA sequences, so you can really very precisely identify these fungi. An unusual aspect, most of these beetle fungi apparently are rather benign to the host they infest. Our fungal species, at least, is not that benign to some host species, and some of them have really very virulent fungal pathogens with them. Not ours, not that virulent. Okay, so here, this is another slide I stole, and so this shows the avocado fungi from Israel, and that's where ours are as well. And these are fungi from another Uwelacia species on Hevea in northern Borneo, and this is another one. And here is where I think the Florida came out of, and here's another one. Anyway, so it also in the fungal systematics, you see that the beetles in Florida differ from the beetles we've got here. Okay, so the biology of the beetles, well, since this is a new species, and in Israel they've been working on it for a couple of years, but here we've just started for the last 4.5 years, we know very little about it, but we do know a bit about this other species that they confuse it with, that it was confused with in the past, and that's the tea-shot hull borer. So this is a pest of tea. It's a pest of tea in southern India and Sri Lanka. There it infests the really small branches of the tea plants. Here we generally don't find our beetles inside branches that are thinner than, let's say, 1¼ inch. The management of these beetles there in tea is very difficult because they're inside the stem. The way they manage it over there, as we learned, is mainly through cultural measures and pruning of infested tea plants, and then destroying the pruned material. And they do not allow castor bean to be grown in areas where they grow tea. So here you see the symptoms in tea stems, and all these little dark spots are the beetle galleries. This is a tea plantation. After they have pruned all the infested bits off of it, then they bury the prunings and the chipping, and they chip the part that they prune off. And they dress the wounds by spraying it with a lime substance. And there that seems to help. And then you get this wonderful fresh-looking tea growth again. Okay, now in Florida, everybody who works with avocados knows about this situation where there's the red bay ambrosia beetle, and that thing is a really nasty, carries with it the nasty symbiotic fungus, which is called the Raffaellia, and it kills red bay laurel trees, and it's also killing avocado trees. It has a large similarity with the Polyphicus shothole borer that we have here, in the sense that it's also an invasive species, apparently also from Asia. It's also an ambrosia beetle, and it spread really rapidly. A difference with the Polyphicus shothole borer is that it has a very narrow host range. It only infests laurel trees and avocado, and it kills trees very rapidly. And they have a relatively effective monitoring method already in place, where they have a lure that works pretty good in attracting the beetles. There, they've been working on it for quite a while, and unfortunately, the control of this beetle appears to be extremely difficult. They don't have any really good insecticides to protect the trees. There's no biological controls available as yet, and sanitation doesn't appear to be too successful, because it often is really difficult to determine whether a tree is infested. By the time it's infested, it's almost too late. So, not a really nice situation, and here is where it's at. Also another stolen slide. Let's say, okay, here are different times. In 2011, they had a large infestation in swamp bays close to avocado commercial areas. And in 2012, they had the first avocado tree that was diagnosed with this disease, laurel wilt, in a commercial avocado grove. So the thing is spreading there quite rapidly. How bad ultimately it's going to be in avocado, we don't know, but we can fear the worst, I'm afraid. Well, we've heard about a Polyphicus shothole borer situation in Israel, so before Mark gets calling me all sort of names, I'm going to just go on. Okay. Biology of the fungus. All right, most ambrosia beetle symbionts are not pathogenic to the host, but they show some low level, so that's what we have here. In other cases, there's a very virulent form. Now, what causes these fungi to be pathogenic in these new environments? Is it simply that they're not associated with their old host and now present with new hosts? Or we really don't know. Are they also pathogenic where they come from? And often we don't really know where they come from, like in our case. Okay, let's hurry up here. Okay, well, the situation in California, well, we've already talked about that. Okay, monitoring and control strategies. The beetle occurs in a very heterogeneous environment. At the moment, it's mainly in the urban forest, and it's not reached commercial avocado yet. And as far as we can tell, it's not yet in our forest, where we worry quite a bit about coastal live oak. And so it occurs in a large number of environments. It's very heterogeneous. Makes, even if we get control strategies, it makes it very difficult to apply, because you don't just go to an orchard and spray the whole thing. Just try spraying the whole of Los Angeles. It's not going to be pretty. So we don't have no effective detection methods yet. The way we do our surveys is we know which street trees are very good at showing the symptoms, and we just drive down the street and we look for the symptoms. We stop and we take a sample, and then we drive on, generally east-west, to see, okay, here we've got a lot of infested trees. We drive a bit further, a couple of miles down the road, every other tree infested, and then we drive a bit further and there's no more infestation. So the thing is still pretty pretty limited, if you call the whole of LA County limited, but we don't know how rapidly it's spreading. We only have one survey point, and that's this year. So at this point, we don't have any effective control methods. We need to study insecticides and fungicides. There's a slight possibility of using insect pathogenic fungi. Cultural methods need to be looked into. There clearly is a need for trying to limit the spread of the beetle to its natural spread by flight. So let's try to limit the movement of firewood. How can we safely dispose infected wood? We need to get the cooperation of nurseries so that infested trees are not sold to distant locations where they can form the source of a new infestation. We talked about the invasion epidemiology. We know very little about all sorts of characteristics, about how fast do these things grow, how far do they fly. We just need to know a heck of a lot more. And here are some of the questions that we need to address. We've been in contact with various federal and state agencies, and we've been talking quite a bit, and we're getting good cooperation. We exchange information, and we get a lot of specimens from them to identify, so they're very well aware of what's going on. What else they're going to be doing depends very much, of course, on how bad this thing is going to be. We think, the way we look at it at the moment, that it's going to be pretty bad, but time will tell. Forest Service in our area has already started to do some surveys in the areas close, the natural areas close to infested urban areas, and they haven't found any beetles yet, but they've just started. So, conclusion. Three? Oh, I'm going to take some time then. At this point in time, no. So at this point, it really looks like this beetle is a very substantial threat to the urban forest, the avocado industry, and the natural forest. We have very few tools for the management of this thing. We really do not have anything we can say, okay, you know, here, throw this on your tree and it's over with. The thing will disappear. What we have been doing in the meeting is we've been making a list of priorities, things we think are really important to address for the scientific community, all the people that were involved. And it was really a very nice meeting. We had a lot of free exchange of ideas, and many connections were made between the different groups. At this point, we're in the very early stages of studying this Polyphacus shothole borer, the thing that occurs here in Israel. In Israel, they started 2 to 3 years ago, or maybe even longer, I'm not quite sure, but we just have been at it for about 5 months. And we clearly need to do a lot more research to find a way to limit the damage that this beetle may cause. And I probably should say something, we need more money, of course, but here are some acknowledgements, the Hofschi Foundation for organizing the meeting, and all the participants that were really very free in exchanging their most recent results. There we go. That's it.